If we take a look at the next one, we're finding the fifth term, given a sub 1 and an r value. Since we have an r value, that means that this is going to be geometric, so we're using a sub n equals a sub 1 times r to the n minus 1. So a sub n, we're looking for a sub 5 here. A sub 1 is 1,458. R is 2/3 to the n minus 1, so that's going to be 5 minus 1. So if we rewrite this, we'll just simplify this. It's going to be to the fourth power, so that's going to be 1,458 times 16 over 3 to the fourth power is 81. And if we multiply these out, we end up with 288. And that's it. So 288 for this one. We take a look at the next one. It says to find the four geometric means between 7 and 224. So I'm looking for four geometric means. So 1, 2, 3, 4. In order to find my geometric means, I'm going to need my r value. So once again, I'm going to use a sub n equals a sub 1 times r to the n minus 1. If I were to label these, this is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. I'm going to use the 224 for a sub n, so 224 equals a sub 1 is 7, then r to the, I'm going to use 6 for my n value because of the 224. So now if I rewrite this, that's 224 equals 7 times r to the 5th. So now we have to divide each side by 7. So 224 divided by 7 is going to leave us with a 32. Now in order to solve this, I've got to take the 5th root of each side. Remember, to take the 5th root on our calculator, it's the same as doing 32 raised to the 1/5 power. So we end up with r equals 2. So we're multiplying by 2 each time, so that means it's going to be 14, 28, 56, 112, and then 224. Alright? If we take a look at this one, it says find the sum of the geometric series. So the sum of a geometric series, remember, is going to be s sub n equals a sub 1 times the quantity 1 minus r to the n all over 1 minus r. So since we're looking for the first 6 terms, so that's s sub 6 equals a sub 1 is the 1/9. This is 1 minus our r value. To get from one term to the next, we're actually multiplying by 3. So that's 3 to the 6th power all over 1 minus 3. So we have 1/9 times 1 minus 3 to the 6th power is 729 all over a negative 2. So that's 1/9 times a negative 728 all over a negative 2. And if I punch this into the calculator, it's going to leave me with a positive 40.4 repeating, which we could write as 40 and 4/9. Okay? If I take a look at the next one, once again we're using our sigma notation here. So it means I'm going to start with a value of 1 and go up to a value of 4. So that means I'm going to have 6 times 2 to the 1 minus 1 plus 6 times 2 to the 2 minus 1, 6 times 2 to the 3 minus 1, and 6 times 2 to the 4 minus 1. So this is going to be 6 plus 12 plus 24 plus 2 to the third power is 8 times 6 is 48. And now I just need to add these together. So when I add these together, that's 6, 42. I lost track here. Let me try again here. 36, that's 42, that's 80, that's 90. All right, and that's it. The next one, we're looking for a sub 1. We're given s sub n. So s sub n equals a sub 1 times 1 minus r to the n, all over 1 minus r. So that's going to be 105 equals a sub 1 times 1 minus a negative 2 to the 6th power, all over 1 minus a negative 2. So it's going to be a sub 1. Let me rewrite this up here a little bit. That's 105 equals a sub 1 times 1 minus 2 to the, or negative 2 to the 6th power is going to give us a positive 64. All over, this is like plus a positive, so that's all over 3. So that's 105 equals a sub 1 times a negative 63 over 3. So that's 105 equals a sub 1 times a negative 21. I have to divide each side by the negative 21. And I find out that a sub 1 equals a negative 5. Alright, so a sub 1 equals a negative 5 for that one. For the next one, I want to find the sum of the infinite geometric series. So this is going to continue forever. So first thing I need to do is find out what I'm multiplying by. So my r value for this one, it looks like I'm multiplying by 3/2. So for each, to get each term, we're multiplying by 3/2. If I look at that r value, since the r value is not between negative 1 and positive 1, that means that this one's going to shoot off to infinity. Okay? For the next one, the sum of the infinite geometric series. Once again, we check our r value. Here our r value is between the negative 1 and positive 1. So we're going to use our formula s equals a sub 1 over 1 minus r. So that's 12 over 1 minus 3/5. So that's 12 over 2/5. Which, remember, dividing by a fraction is the same as multiplying by the reciprocal. So that's going to give us a 30. Okay? And then the last one, we can use our shortcut on this one. If I have 0.42 repeating, there's 2 digits repeating, so I write the 2 repeating digits over 2 9s, so 99. And now I just need to reduce this. Each of these is divisible by 3. 42 divided by 3 is 14. 99 divided by 3 is 33. So it's 14/33. All right. Hope this was helpful, and good luck on your test tomorrow.